Hello everybody. In this example, we will apply Newton's laws of motion to analyze what we call the Atwood machine. Now the Atwood machine basically consists of two blocks, 1 and 2. Most often one of the blocks is heavier or more massive than the other around a pulley. We're going to make a fundamental assumption in this problem that the pulley is massless. Now, the consequence of that assumption is that the tension in the string remains the same. So our task or objective of this problem is to determine 1, the acceleration of the system, and 2, the tension in the string. Now, as usual, whenever you are given a problem like this, the very first thing that you do is to draw your free body diagram. Now, before I do my free body diagram, let's annotate the diagram. Obviously, the system will accelerate in the side of block A. Now we are going to take the direction of motion to be positive. Block 1 accelerate upwards and block 2 accelerate downwards. So we will take to be positive. Now, remember, we will take the direction of motion to be positive, and we will apply Newton's second law for block 1 and Newton's second law for block 2. So for block 1, we have the summation of F equal to T M1G equal to M1A. For block 2, we have the summation of F equal to M2G minus T equal to M2A. Let's call this equation 1 and let's call this equation 2. Now there are one or two ways we could solve this equation. We could either add equation 1 to equation 2. If we do that, we will have M2G, T minus T is 0, so this is M1G equal to M1A plus M2A. That means that M2 minus M1 all G equal to M1 plus M2 bracket A. Therefore, the acceleration A is equal to M2 minus M1 divided by M1 plus M2 all multiplied by G. This gives you the acceleration of the system. Now that we know the acceleration of the system, we will substitute this acceleration into one of these equations to calculate the tension in the string. So let's take equation 1 for example. T will be equal to M1A plus M1G. That means that T is equal to M1 all multiplied by M2 minus M1, M1 plus M2, G plus M1G. So this will be equal to M1, M2 minus M1 squared divided by M1 plus M2 G plus M1G. We can further simplify as M1, M2G, M1 squared G plus M1 squared G plus M1, M2G, all divided by M1 plus M2. You see that this cancels with this, And T simplifies to, T will become this plus this, which is 2m1 m2 divided by m1 plus m2g. So this gives us the tension in the spring. When you are reviewing this video, please take note of this algebra here. It's basically your simplifying fractions. It's more here algebra than physics. Thank you so much for your time. I hope that this example will help you understand how to apply Newton's laws in solving the Atwood machine. Remain blessed. Thank you.